The air returns to the cabin through a charcoal filter, which removes odors. The system collects solid wastes in a semi-permeable bag, which retains liquids and solids, but allows air to flow through. Airflow directs the waste products to the bottom of the bag. The user seals the bag and transfers it to a vacuum dryer. A small amount of heat and an outlet to the vacuum of space removes the moisture, which inhibits bacterial growth. The crew stores the dried wastes in sealed canisters. Personal hygiene is an essential element of normal living. Shaving, bathing, and keeping the hair neatly trimmed satisfy both a physical need for cleanliness and contribute to psychological well-being. The design of personal hygiene equipment must consider the zero-gravity environment and the possibility of contaminating the atmosphere. For example, the zero-G razor vacuums the whiskers as it shaves. For bathing, the sponge appears to be the most practical in terms of weight, power required, and as a means for solving the no-gravity problem. But even the simple matter of filling and emptying a sponge is a problem. Squeezing forces the water out, but instead of falling, it gathers into an undulating glob. The slightest motion sends it floating across the cabin. The crew will use a manually operated wetter squeezer, which fills or empties the sponge, transferring the used wash water to the recovery tank. A non-toxic antiseptic detergent is added to the preheated bath water as a cleansing agent. In space, oral hygiene is less convenient than on Earth. The toothbrush user will have to keep his mouth closed while brushing. Basically, there are no major technical problems in personal hygiene. However, it will undoubtedly require considerable effort on the part of the crew to adjust to new methods of doing many commonplace things in their new weightless world. Thus, we have a life support system, a combination of atmospheric control, water regeneration, food management, waste management, and personal hygiene. Superimposed over these is the requirement for a thermal control system, which keeps the total life support functions in a thermal balance. The life support system is a closely knit, highly integrated system, tied together with many common bonds, functioning in many respects like the human body it serves. Man, a living, breathing organism, and a machine that functions like an organism, inseparably tied together. The design concepts and scientific processes incorporated in this life support system present the research tool required to design the advanced life support systems for the men and spacecraft that will be making extended exploratory trips into space.